Yesterday we were talking about working with customary measures. We did a lot with adding and subtracting. Today we're going to do a little bit more with them, but we're going to focus on multiplying and dividing. And we're, again, only going to be working with the US customary measure. So we're not dealing anything with the metric system yet. Similar to what we were doing yesterday with adding and subtracting, if you're multiplying a customary number to another one, you want to think about like especially if you got more than one unit. So like yesterday we saw a lot with like pounds and ounces. You want to only take the number times like each one individually. So you'll take it times the ounces and times the pounds. And then if you need to rewrite something so that it's back in that standard notation like we saw yesterday, then you'll do that as like a last step. So, for example, a tank holds 21 gallons and 3 quarts of weed killer. How much would 8 containers hold? So we're going to take the 21 gallons and 3 quarts. We're going to take that times 8. So we're going to do 8 times each number. So 3 times 8 would be 24. We have 24 quarts. And then 21 times 8 would be 168. And so that would be gallons. So let's think about the 24 quarts for a second. How many quarts are in 1 gallon? 4. So if I took 24 and if I divide that by 4, that would give me the number of gallons that I have. And since 4 goes into that nicely, this becomes 6 gallons. So I actually have 168 gallons plus the 6 gallons. So I have a total of 174 gallons. This also is used a lot when we think about finding area of something. Area is used when you're looking at the measurements of a room or a space or something and you're trying to figure out like how much material you need to cover the entire thing. So this would be just multiplying length measures times another length measure that are similar. So you're taking inches times inches or feet times feet. And you could also do this with anything in the metric system too, but you're going to see mainly our system. So they're talking about, for this example, a desktop is 2 feet by 3 feet. What is the number of square feet in the surface? So a desktop would be like your computer screen. And so normally they're rectangular shaped. So we're going to take, for areas like a rectangle, would be length times width. So we're going to take the 2 feet times the 3 feet. 2 times 3 would be 6. Since we're talking about area, area is always the unit squared. So it would be feet squared. So dividing works the same as multiplying does. If you have a measurement, if there's a lot of different types of measurements, so if it's in yards, feet, and inches, you take each one divided by the number that you're working with. So you divide them all by 3 or you divide them all by 5 or whatever it would be. And then again, if you need to, you can always rewrite it in standard notation like we did with that first one with the gallons of the weed killer. So this one is wanting to know how much milk is needed to half a recipe. So you're cutting it in half. The original recipe calls for 2 gallons and 2 quarts. So we're going to take 2 gallons and 2 quarts. We're going to divide each of those numbers by 2. So this one works nicely because it goes in evenly, because 2 divided by 2 would just be 1. So we would need 1 gallon and 1 quart. Now, unfortunately, they're not all going to be that nice. Okay, there's going to be some that when you go to divide, it doesn't go in evenly. So it's not going to be like always 3 divided by 3 or even like 6 divided by 2. That would be easy, but you're going to have some where the number that you're dividing by doesn't go in as nicely. And when that happens, these take a little bit more work because you have to think about when you were dividing numbers for the first time, and it didn't go in nicely, and you guys were learning how to do long division back in elementary school. Okay, a lot of times that's when we started having like remainders and decimals, and then that's how those kind of things came about. So I'm going to show you guys an example. This up here at the top is kind of the steps that you want to follow through. So we set them up as a long division problem. When you get to your remainder, you're going to want to convert it to the next unit that you're working with. So if you have yards, feet, inches, you're going to divide by yards first. When you get to your remainder, you're going to convert the remainder there to inches, add it to the inches that you have, and then do long division again, or to feet, and then you'll do it to inches for the last one. So I'm going to show you how to do this. Like I said, this is going to take a little bit more time, just because it doesn't work out as nicely. So we're trying to take 5 gallons, 3 quarts, and 1 pint. We're trying to divide them all by 3. So, 3 is not going to go into 5 gallons nicely. So we got to first set this up as a long division problem. So I'm trying to figure out my gallons first. So how many times can 3 go into 5? Whole times. 1. So I'm going to put 1 up here. So 1 gallon. So 3 times 1 would be 3. This is still in gallons here. If I subtract, I get 2 gallons. This is your remainder. Now we want to take gallons, the 2 gallons, the remainder, convert it to quarts. So how many quarts are in a gallon? 4. There's 4 quarts in a gallon. So I'm going to take 2 times 4, and that gives me 8 quarts. So what I do with the 8 quarts is I look up here, and I've got 3 quarts in my original problem. So I need to add 3 to that 8, which is going to give me how many? 11. Okay, so now we do this again. This time, instead of 3 quarts, I'm now up to 11 quarts because I took my remainder and I added it to the quarts that I had in the original problem. So I'm taking 3 and I'm trying to go into 11 quarts now. So how many times can 3 go into 11? 3 times. So 3 quarts, 3 times 3 would be 9. Subtract. 11 minus 9 would be 2. So 2 quarts is my remainder. Now I got to get quarts to pints. How many pints are in a quart? 2. There's 2 pints. So now I'm up to 4 pints. How many pints did I start with in my problem now? Up at the top? 1. So we got to add 1 to it. So I'm just going to scoot over here. So now I've got 5 pints. We're going to do this one last time. So I'm going to take 3 and divide it into 5 pints. So 3 can go into 5 one time. So we have 3 pints, and when we subtract, we get a remainder of 2. Okay, so we can't convert this anymore because the problem had gallons, quarts, pints. What we have, if we come out and we look at this whole problem here, and I have to go out a little bit so you can see everything. Right now we have full units. We have 1 gallon, 3 quarts, and 1 pint. But how do we take care of this remainder? Because we still have 2 pints and then that 3 that we're dividing by. So remember when you guys did long division a normal way with just plain numbers, no units? Your remainder was always written as that number that you're left at the bottom over what you divided by. So for this one, you're going to have 1 gallon, 3 quarts, and then it's going to be 1 2/3 pints. And that 2/3 comes from that remainder 2 over what we divided by 3 at the end. Because I still have this 2 pints here. I got to figure out how to write that. So we write it as the fraction, as the remainder. This would be your final answer here. 1 gallon, 3 quarts, 1 2/3 pints. It's not super common to have to do something like that. Usually, like recipes are already set up that, especially like this would be used a lot if you're cooking, okay? Usually recipes are already set up that you're only doing like 1 cup or 1 pint or something of something, and so dividing it in half is easy. But there are times that you maybe have to divide it into thirds, or even like multiplying, like you have to expand it because you're making it for like a graduation party or something like that. And you got to figure out how much more am I going to need for all these other people. So that's when you would use a lot of this. But like I said, most of the time, You won't have something like this one as long because usually measurements are easy to like cut in half or even multiply by instead of having to do this long division. Okay, so let's see what's next here. Dividing a customary measure by a customary measure. So we've kind of talked about this. If they're different measurements, so if you're trying to take feet and divide by inches, you want to get them to both be in the same measurement first. Just like if you were multiplying for area, you want to know what the dimensions of like this room would be in feet. I don't want one measurement to be in feet and one to be in inches. Because then if I multiply, I'm going to get way too big of a number. I'm going to order way too much stuff. So you want to make sure that your measurements are consistent. So this one says that tubing is manufactured in lengths of 8 feet 4 inches and a part is 10 inches long. How many parts can be cut from the length of tubing if we do not account for waste? So let's take a look first at the 8 feet 4 inches. So each part is 10 inches long. That's what we're going to be dividing by. So I need to convert 8 feet 4 inches to inches. How many inches are in a foot? 12. So to take 8 to inches, 8 feet, we're going to take 8 times 12. Anyone know what that would be? 96. So I've got 96 inches, and I'm going to add that to the 4 inches. So I've got a total of 100 inches. Now if I go to divide, I'm taking 100 inches divided by each part, which is 10 inches long. So how many parts can be made? 10. And again, that's assuming that there's no waste done with each cut. Like each cut is clean and I'm not wasting off anything. Okay, so we've got one last thing to talk about, and this is starting to include some time. So we're talking about like a rate measure, which would be a ratio of two different kinds of measures. And I alluded to this a little bit yesterday when I said that there's going to be times when you have to do dimensional analysis, when you've got something going like feet per second and you want it to be miles per hour instead. So you have to do two different conversions. You have to do the feet to miles and the seconds to hours. A lot of times those are referred to, like I said, as rate. So that would be like how fast something's going at speed. And the word per, when you hear that, so like when they say feet per second or miles per hour, per means division. Or you can also think of that as like a fraction. So if it's miles per hour, you're figuring out how many miles are you traveling for every 1 hour. If it was feet per second, it would be how many feet are you traveling for every 1 second of time that passes. So this gives you some conversions for time, which most of these we probably already know because we know how many hours are in a day, how many hours or how many seconds are in an hour and that kind of stuff. Now for the 1 year stuff, they're not accounting for leap years. Okay, we're just assuming that all years have 365 days because most of them do. So when you see something like that, always just use 365. In order to convert them, this is when, like I said, dimensional analysis will come back in. So you might want to set up a series of fractions to help you convert, and you might have to just keep track of which label you have left to change. So if we turn our page over, we're going to just end with a couple of examples on this. So I want to change for this first one. It says we have 8 pints per minute. I want to change it to quarts per minute. So when I see 8 pints per minute, I'm assuming that means that they're doing 8 pints for every 1 minute. So this could be like in a factory, something's filling something, and it's filling 8 pints for every 1 minute. So I need to get quarts to minutes. I'm sorry, pints to quarts. I don't need to do anything to my minutes for this one. So think back to what we just talked about this a little bit ago. How many quarts are in a pint? 2. So what we're going to do is set up, and remember you always want your labels to be on opposite heights, so you want to drop pints to the bottom. So 1 pint is the same thing as 2 quarts. I don't have to do anything to the minutes, because if I kind of cancel off my labels, my pints are gone, And now I have quarts over minutes, which is what they want. So I don't have to change minutes to anything. So what I'm going to do is I'm going to take 8 times 2. Oh, I think I put my numbers on the wrong spot. You can see what I did? Right? Because we're going pints to quarts. Quarts would be bigger than pints. So it should be 1 over 2 instead of 2 over 1. There's 2 pints for every 1 quart. I wrote it upside down. So now we have on top 8 times 1, which is 8. On the bottom, 1 times 2, which would be 2. So 8 divided by 2 would be 4. So they're doing 4 quarts per minute. All right, last one on here. Number 2 says change 60 miles per hour to feet per second. So we're going to start with 60 miles over 1 hour. So we need to set up a couple of fractions here because we got to get miles to feet, hours to seconds. What do you guys want to change first? You guys want to change miles or hours? Hours? So let's get hours to seconds. Let's do hours to minutes first. How many minutes are in an hour? 60. So make sure that you put 1 hour on top because you want hours to cancel. So then we put 60 minutes on the bottom. And so then how many seconds are in a minute? 60. So how would I write this one? Would I do like 60 seconds on, why on the bottom and not on top? So I want 1 minute to be on top, 60 seconds to be on the bottom. That way if I look here, notice that hours, you've got 1 on the bottom, 1 on the top, so they cancel out. You've got minutes, 1 on the bottom, 1 on the top, so they cancel out. And I'm left with seconds, which is what I wanted to get to. Now I got to get miles to feet. How many feet are in a mile? Okay, so where, like how do I set this fraction up? What number goes where? 1 mile, would I go on the top or on the bottom? Bottom. And 5,280 feet would go on top. So then again, at my miles, I've got 1 on top, 1 on the bottom, they cancel. So to finish out, you need to multiply again across the top and across the bottom, and you might have to do division at the end. So you're going to take 60 times 1 times 1 times 5,280, or just take 60 times 5,280. That's going to give you, on top, 316,800. And then on the bottom, you've got 1, 60, 61, which would be 3,600. And so what did you get for final answer? 88 feet per second.